Picture yourself in the vast expanse of space, where an extraordinary phenomenon challenges our understanding of planetary systems. Drifting alone through the cosmic void, a massive world travels without a star to call home, lost in perpetual darkness. While this might sound like a concept straight from science fiction, these wandering worlds are very real. These fascinating celestial bodies, known as rogue planets, represent one of astronomy's most captivating mysteries, inviting us to explore a phenomenon that pushes the boundaries of our cosmic understanding. The sheer scale of this astronomical wonder is mind-boggling. Within our Milky Way galaxy alone, scientists have estimated the existence of billions of these solitary travelers silently journeying through interstellar space. Even more astonishing is their incredible diversity. Some of these nomadic worlds dwarf our largest known planets, reaching sizes up to twice that of Jupiter, our solar system's biggest planet. These cosmic wanderers challenge our traditional views of planetary formation and behavior, offering unique insights into the complex dynamics of galactic evolution. As we embark on this fascinating journey together, we'll explore how these celestial nomads compare to the familiar planets we've studied for centuries, those that, like Earth, follow predictable orbits around their parent stars. The story of these rogue planets opens up new chapters in our understanding of the universe, revealing that the cosmic landscape is far more diverse and dynamic than we once imagined. From their mysterious origins to their lonely journeys through space, these wandering worlds represent one of the most intriguing frontiers in modern astronomy, promising to reshape our understanding of what it means to be a planet in our vast universe. Deep in the cosmic wilderness, a fascinating category of celestial objects challenges our traditional understanding of what defines a planet. These mysterious wanderers, officially known as rogue planets, but also called orphan or free-floating planets, represent a unique class of worlds that defy conventional planetary definitions. Unlike the familiar planets that faithfully orbit their parent stars, these nomadic worlds drift freely through interstellar space, untethered from any stellar companion. The story of rogue planets reads like a cosmic tragedy. According to Dr. Rebecca Jensen-Clem, a distinguished astronomer at the Gemini Observatory, many of these lonely travelers likely began their existence much like our own planets, within the warm embrace of a solar system. However, their fate took a dramatic turn through catastrophic events of almost unimaginable scale. These cataclysmic occurrences, which could include violent gravitational interactions with larger planets or nearby passing stars, literally hurled these worlds out of their home systems, casting them into the vast darkness of interstellar space. The physics governing these planetary outcasts presents a fascinating paradox. Free from the gravitational bonds that typically define planetary motion, these worlds chart their own paths through the galaxy. They move through the cosmic void, responding only to the broader gravitational influence of the galaxy itself, much like stars do. This independence, while making them incredibly difficult to detect, also makes them unique laboratories for understanding planetary evolution outside the influence of a host star. Perhaps most intriguingly, these planets exist in a state that challenges our Earth-centric views of planetary environments. Without a star to provide light and energy, these worlds exist in perpetual darkness, their surfaces likely frozen to temperatures approaching absolute zero. Yet, some scientists speculate that beneath their frozen exteriors, some larger rogue planets might harbor internal heat sources, potentially creating conditions that, while alien to our understanding, might still support some form of internal activity. The discovery and study of rogue planets represent one of modern astronomy's most significant contributions to our understanding of planetary formation and evolution. These celestial nomads remind us that the universe is far more dynamic and diverse than we once imagined, with planetary systems capable of dramatic changes over time. As our detection methods improve and our understanding deepens, these mysterious wanderers continue to challenge and expand our definition of what constitutes a planet in the vast cosmic ocean. The story of planetary formation reveals two distinct yet interconnected paths in the cosmic dance of creation. To understand the unique nature of rogue planets, we must first explore the more familiar process that gives birth to traditional planets within established solar systems. Traditional planets emerge through a magnificent cosmic ballet that begins in the swirling disk of gas and dust surrounding a newborn star. This protoplanetary disk, a remnant of the same stellar nursery that formed the central star, contains all the building blocks necessary for planetary formation. Within this cosmic cradle, tiny particles of dust and ice begin a remarkably patient process of growth. Through countless gentle collisions, these microscopic particles gradually combine to form increasingly larger bodies, from grains of sand to pebbles and eventually to planetesimals. Over millions of years, this accretion process continues relentlessly. The larger these growing bodies become, the more material they can attract through their increasing gravitational influence. The process accelerates as these protoplanets sweep up surrounding material like cosmic vacuum cleaners, clearing their orbital paths and establishing the stable, nearly circular orbits we observe today. The gravitational embrace of their host star acts as an anchor, maintaining these orderly orbital patterns that can persist for billions of years. However, the formation story of rogue planets follows a more complex and often tumultuous path. Some of these wandering worlds begin their existence just like traditional planets, nestled within the protective confines of a protoplanetary disk. Yet their destiny takes a dramatic turn through various cosmic circumstances. The most common scenario involves violent gravitational interactions within their original solar systems. When multiple massive planets form within the same system, their gravitational dance can become chaotic. Like cosmic billiard balls, these interactions can result in planets being violently ejected from their home systems, cast into the interstellar void. Even more intriguingly, astronomers have discovered that some rogue planets may form through an entirely different mechanism. In particularly dense regions of molecular clouds, concentrations of gas and dust can sometimes collapse directly under their own gravity, forming planetary mass objects without ever being part of a solar system. This process, while rarer, suggests that the line between planet and failed star formation might be more blurred than previously thought. The ejection process itself can occur through several mechanisms. Sometimes, it's the result of a close encounter with a passing star that disrupts the delicate gravitational balance of a planetary system. In other cases, the culprit might be the chaotic early period of a solar system's evolution, where newly formed planets compete for stable orbits. The strongest survive in stable configurations, while others are literally thrown out of the system entirely. These dramatic events can accelerate these orphaned worlds to speeds of tens of kilometers per second, sending them on eternal journeys through interstellar space. What makes this topic particularly fascinating is how it challenges our traditional understanding of planetary formation and stability. The discovery of rogue planets has forced astronomers to reconsider their models of solar system formation and evolution, suggesting that planetary systems are far more dynamic and prone to change than previously thought. These cosmic wanderers serve as crucial evidence that the story of planetary formation is far more complex and varied than we once imagined. The environmental conditions on planets across our universe present a stark contrast between worlds that bask in stellar light and those that drift in perpetual darkness. This fascinating comparison reveals how a star's presence, or absence, fundamentally shapes a planet's character and potential for various physical processes. Traditional planets, like those in our solar system, exist in a complex dance with their host stars, which provide a constant source of energy that shapes every aspect of their environments. These worlds receive a steady stream of light and heat, creating dynamic systems that drive weather patterns, seasonal changes, and potential chemical processes essential for life as we know it. The regular input of stellar energy allows these planets to maintain relatively stable surface temperatures, which can range from the scorching heat of Mercury to the frigid conditions on Neptune, yet remain consistent enough to support lasting atmospheric conditions. The presence of a host star also creates one of the most fundamental rhythms we know, the cycle of day and night. This alternation, combined with a planet's axial tilt, generates seasonal patterns that can drive complex atmospheric and oceanic circulation patterns. On planets with substantial atmospheres, these energy inputs can create elaborate weather systems, cloud formations, and precipitation cycles. The relatively stable conditions allow for the long-term retention of atmospheres, which can protect the surface from harmful radiation and help regulate temperature through greenhouse effects. In dramatic contrast, rogue planets present us with some of the most extreme environments imaginable. Drifting through the darkness of interstellar space, these worlds exist in a state of perpetual night, their surfaces plunged into temperatures that would freeze most gases into solid form. Typically, these planets experience temperatures below 200 degrees Celsius, 328 degrees Fahrenheit, making them some of the coldest bodies in the universe. However, the story of rogue planets isn't simply one of eternal darkness and cold. Some of these worlds might experience a subtle form of illumination through atmospheric luminescence, a phenomenon similar to Earth's aurora borealis, but potentially occurring across the entire planet. This faint glow, while not providing significant heat, could create a hauntingly beautiful spectacle of perpetual twilight. Perhaps most surprisingly, some rogue planets, particularly the larger ones, might harbor hidden sources of warmth. Deep beneath their frozen surfaces, these worlds could maintain significant internal heat through various geological processes. Radioactive decay within their cores, tidal heating from any moons they might have retained, and residual heat from their formation could all contribute to internal warming. This internal heat could potentially create subsurface oceans, hidden beneath thick layers of ice, much like what we observe on some of Jupiter's and Saturn's moons. The atmospheres of rogue planets, if they managed to retain them, would be fundamentally different from those of traditional planets. Without stellar radiation to drive complex weather patterns, these atmospheres might be more stable, but also more stratified. Any atmospheric movement would likely be driven primarily by internal heat, rather than external energy sources, creating unique circulation patterns unlike anything we observe in our solar system. These extreme conditions make rogue planets invaluable natural laboratories for understanding planetary processes in isolation from stellar influence. They help us understand how planets might retain and distribute heat, maintain atmospheres, and potentially even harbor subsurface environments that could, theoretically, support simple forms of life in conditions radically different from what we're familiar with on Earth. If you find these discoveries as fascinating as I do, please like and subscribe to the channel. That way, you won't miss any of these incredible journeys through the cosmos. The quest to discover and understand planets beyond our solar system represents one of modern astronomy's most remarkable achievements. The methods and challenges involved in detecting these distant worlds differ dramatically depending on whether we're searching for traditional planets, orbiting stars, or their elusive cousins, the rogue planets drifting through interstellar space. For traditional planets, astronomers have developed an impressive arsenal of detection techniques. The transit method, perhaps the most prolific, watches for the subtle dimming of a star's light as a planet passes between it and our telescopes. This tiny eclipse, while barely noticeable, creates a distinctive signature that not only reveals the planet's presence, but also provides valuable information about its size and orbit. The Kepler Space Telescope alone has discovered thousands of planets using this method, revolutionizing our understanding of planetary systems. Another powerful technique is the radial velocity method, which detects the minute wobble in a star's motion caused by the gravitational pull of its orbiting planets. As planets orbit their star, they cause it to move in a tiny circle or ellipse, creating subtle shifts in the star's spectrum that we can measure with extremely precise instruments. This method has proven particularly effective at finding massive planets close to their stars. Direct imaging, while more challenging, provides perhaps the most compelling evidence of exoplanets. Using advanced telescopes equipped with coronagraphs to block out the overwhelming glare of host stars, astronomers can actually capture images of some planets. These tend to be young, massive planets orbiting far from their stars, but the direct views they provide are invaluable for understanding planetary characteristics. The study of traditional planets benefits enormously from their predictable orbits. When a planet transits its star, astronomers can analyze the starlight filtering through its atmosphere, revealing detailed information about its composition. Regular observations over time can track orbital changes, weather patterns, and even search for signs of seasonal variations. However, detecting and studying rogue planets presents a far more formidable challenge. Without a host star to provide a reference point or regular orbital patterns to predict their location, these cosmic wanderers require different detection strategies. The primary tool in this hunt is gravitational microlensing, a phenomenon predicted by Einstein's theory of general relativity. When a massive object passes between Earth and a distant star, its gravity acts like a lens, temporarily magnifying the star's light in a distinctive pattern. If that lensing object is a rogue planet, its gravitational signature creates a unique and identifiable signal. As Professor Michel Mayor, whose pioneering work led to the discovery of the first confirmed exoplanet orbiting a sun-like star, has noted, these wandering worlds provide crucial insights into planetary formation dynamics. Each detection helps us understand how planetary systems evolve and how frequently planets might be ejected during their formation. The very existence of these objects challenges and refines our models of how planetary systems form and evolve over time. The observation of rogue planets remains one of astronomy's most challenging endeavors. Without a star's light to analyze or regular orbital patterns to predict their location, gathering detailed information about their physical characteristics requires pushing our observational techniques to their limits. Advanced infrared telescopes can sometimes detect the faint heat signature of younger, more massive rogue planets, while careful analysis of microlensing events can provide estimates of their masses and distances. As our detection technologies continue to advance, particularly with the deployment of more sensitive space-based telescopes and larger ground-based observatories, our ability to find and study these elusive worlds improves. Each new discovery adds another piece to the puzzle of planetary formation and evolution, helping us better understand our place in the cosmic tapestry. Our journey through the fascinating world of rogue planets reveals a universe far more dynamic and mysterious than we once imagined. These solitary wanderers, drifting through the vast cosmic ocean, challenge our traditional understanding of what constitutes a planet and how planetary systems evolve. Their very existence tells us that the story of planetary formation and evolution is far more complex and dramatic than we previously understood. Each new discovery of these celestial nomads adds another layer to our understanding of cosmic evolution. These lonely worlds serve as silent witnesses to the violent processes that can tear apart young planetary systems, while simultaneously highlighting the resilience of planets that can continue their journey through space, even without a star to call home. The fact that billions of these worlds might exist in our galaxy alone suggests that planetary formation is a robust process, capable of producing worlds in circumstances we never thought possible. The study of rogue planets reminds us that we stand at the threshold of even greater discoveries. As our technology advances and our methods of detection become more sophisticated, we are likely to uncover even more surprises about these mysterious travelers. They represent not just an interesting astronomical phenomenon, but a testament to the incredible diversity of planetary bodies that exist in our universe. From frozen giants drifting in eternal darkness to smaller worlds that might harbor hidden oceans beneath their icy surfaces, each rogue planet tells its own unique story of cosmic evolution. Looking ahead, the field of rogue planet research promises to continue yielding fascinating discoveries. These wandering worlds serve as natural laboratories for understanding planetary evolution in extreme conditions, potentially helping us understand how planets might survive and even thrive in the absence of stellar warmth. Their study pushes the boundaries of our observational capabilities while simultaneously expanding our theoretical understanding of planetary formation and survival. If you found yourself captivated by these cosmic wanderers as much as I have, I encourage you to join me on this ongoing journey of discovery. By subscribing to Exploring the Universe, you'll be part of a community of curious minds, eager to uncover the mysteries of our cosmos. Every like, share, and subscription helps us reach more people who share our fascination with the universe's endless wonders. Together, we can continue to explore and understand the most intriguing phenomena our universe has to offer, from the familiar planets of our solar system to the mysterious rogue worlds that roam the galactic wilderness. Let's embark on future cosmic adventures together as we continue to unravel the mysteries of these fascinating celestial nomads and the countless other wonders that await our discovery in the vast expanse of space. The story of rogue planets is far from over, and who knows what other astronomical marvels we'll uncover in our ongoing exploration of the cosmos.